We're about to drop a nuclear reactor on the moon. And no, this isn't the plot of the next sci-fi blockbuster. That single sentence should make your ears perk up, because it captures the bizarre yet real race now unfolding 384,000 kilometers above our heads. Forget footprints and flag planting. The 21st century lunar contest is about kilowatts and kilograms of enriched uranium. China says it will have a lunar nuke coming by 2035. The United States just counterpunched, vowing to flip the switch on an American reactor by 2030. But here's where it gets controversial. Whichever nation powers up first may quietly rewrite the rulebook for who gets to do what and where on the moon for the next 50 years. And this is the part most people miss. None of this is technically illegal. Surprised? Let's unpack why. From Cold War batteries to tomorrow's lunar cities. Nuclear energy in space isn't new. Since the 1960s, NASA and the Soviet, later Russian space agencies have tucked grapefruit-sized chunks of plutonium into spacecraft to keep Voyager talking, Curiosity roving, and Cassini snapping photos of Saturn's rings. These radioisotope thermoelectric generators, RTGs, are the great-grandparents of the mini reactors now on NASA's drawing board. Fast forward to 2025, NASA and the U.S. Department of Energy have spent the better part of a decade refining fission surface power units, essentially bite-sized nuclear plants that can fit inside a lunar lander. Think of them as souped-up RTGs on steroids, able to pump out 10 kilowatts of continuous electricity for a decade without refueling. That's enough juice to run a small neighborhood on Earth or a thriving lunar mining camp. The law already has a seat at the table. Cue the space lawyers. Yes, we exist. The United Nations 1992 principles relevant to the use of nuclear power sources in outer space act like a cosmic safety manual. They don't ban reactors. They simply demand transparency, safety reviews, and advance notice to other nations. In plain English, you can bring the nuke, but you have to tell everyone how you'll keep it from turning the moon into a radioactive golf course. Nothing in the venerable 1967 Outer Space Treaty outlaws peaceful nuclear power either. What it does say, buried in the lawyerly prose of Article 9, is that every country must act with due regard for others. Translation: if the U.S. plops a reactor near the lunar South Pole, China, India, or Luxembourg can't bulldoze it out of the way. The reactor safety perimeter effectively becomes a soft border, shaping traffic patterns for rovers, landers, and future bases. Why first equals de facto landlord. Imagine staking a tent at the only freshwater spring in a desert. You haven't claimed the desert, but you've certainly claimed access to the water. A lunar reactor works the same way. Plant it beside a crater packed with ice, and you secured a power source for electrolysis plants that turn that ice into rocket fuel and drinking water. Other nations can still visit, but they'll need your permission, or at least your power to stay long-term. Controversial take. Some legal scholars argue that this skirts dangerously close to a de facto territorial claim, even if the treaty text forbids sovereignty. Is a 10-kilometer keep-out safety zone around a reactor really that different from planting a flag and calling dibs? Drop your thoughts below. Should we tighten the rules, or is this just smart logistics? Solar's Achilles heel on the moon. But why nuclear at all? Can't we just use solar panels? Great question, until you remember that lunar night lasts 14 Earth days. During that fortnight-long blackout, batteries big enough to keep life support running would weigh more than the entire lander. Add in the permanently shadowed craters, prime real estate for water ice, and solar becomes impossible. A reactor, on the other hand, keeps humming in pitch darkness, minus 250 degrees Celsius cold, and micrometeorite sandstorms, radiation fears, and the knot in my crater. Problem. Let's address the elephant, or should we say the radioactive elephant in the room. Critics worry about meltdowns, contamination, or a launch explosion scattering fallout across Florida. Fair concerns. Yet modern small modular reactors, SMRs, use passive cooling. No pumps, no moving parts, no human intervention required. If something goes sideways, the reactor shuts itself down like a self-snuffing candle. Still, perception matters. One botched launch could spark global outrage and knee-jerk bans. So here's a spicy question. Should lunar reactors be governed by an international watchdog with inspection rights? Or is that an overreach that would stifle innovation? Sound off in the comments. Are you team transparency or team sovereignty? Infrastructure is the new flag. Back in 1969, planting a flag was symbolic. In 2030, planting a reactor is strategic. It says, we're here, we're staying, and we have the watts to prove it. The country that masters lunar nuclear tech first won't just light up habitats. It'll set the default standards for safety zones, frequency allocations, and even dispute resolution protocols. Think of it as the difference between owning the only gas station on a cross-country highway and merely being another driver. A governance gap waiting to be filled. The United States has a golden opportunity, not just to be first, but to be fairest. By publishing reactor designs, inviting international scientists to peer review safety plans, and offering surplus kilowatts to partner nations, Washington could brand itself as the Switzerland of space power, neutral, reliable, indispensable. Fail to do so, and the vacuum will be filled by competing blocs, each guarding their own glowing turf. So, what do you think? Is a lunar reactor a peaceful power plant or a Trojan horse for lunar dominance? Should we applaud the engineering audacity or slam the brakes until stricter global treaties are in place? The moon is about to get its first utility bill. Let's decide who gets to sign the check. Drop your hot takes below. Visionary infrastructure or cosmic land grab?